Okay, so today what we're going to do is we're going to look at how the order of operations changes when you have a fraction, how to determine something called the absolute value, which is something we've looked at briefly, but we didn't determine say it in those terms. And then finally, if time permits, we'll be looking at square roots, right? And I'll talk to you about what that means and how to find them. Okay? So we're going to begin with fractions, because when you're talking about working with the order of operations, if you have fractions in your problem, then there is an order of operations for how you simplify that fraction. So what you need to remember is that when you have fractions, with operations in them, then you need to be careful about what you do first. Now, the order of operations still holds true, but because you have a fraction has two parts, yes? It has the top part, which is called the numerator, the bottom part, which is called the denominator. Excellent. Okay? And so you need to deal with each one of those separately. So when you have a fraction, your first thing you're going to do that has operations in it. Now, if it's just like 1/3, who cares? It's done, right? But I'm talking about if it has some addition or multiplication, you'll see exactly what we look like when you look at an example. The first thing you'll do is simplify in the numerator. So if there are any brackets, indices, exponents, right? Addition, subtraction, multiplication, and division, you would deal with all of that, clean it all up, get it simplified as possible first. Second, you will simplify. Okay, let's try to fix that. Simplify the denominator. Again, just by following the order of operations, right? Go through the order of operations for the denominator. And then you have to remember, because it's a fraction, what does that fraction bar mean to do? It means to divide. But can you always divide everything? No, but sometimes you can reduce or simplify the fraction. So if there's any factor that will divide evenly into both of them, then you need to divide that out, right? So you'd never leave 2 over 4. You divide them both by 2 and get 1 over 2, right? So you'd always remember that in the end, you must simplify that fraction by either dividing the numbers that you get or just reducing the fraction. Reduce or simplify the fraction. So let me just give you an example of what I'm talking about here, and then we'll go to the book and do some more in a bit. Okay? So say, for example, we have 3 minus 2 times 5 over 2 times 4 plus 3. Now, this is probably going to make a big mess, but who cares? Because I just made those numbers and operations up. All right, so here we go. It's a fraction, but notice this fraction's bigger than just like 1/2 or 1/3. So what we have to do is we have to simplify it before we can do the division with the fraction bar. Because even though the fraction bar means divide, we have too much junk in the top and too much junk in the bottom to actually do that division yet. So what we'll do is we'll just apply the order of operations first to the what? To the numerator. Good. So in the numerator, okay, again, watch your signs. In the numerator, I have the minus, which means combining, and then I have a multiplication. So which one do I do first? And the multiplication I'm working with here is not just 2 times 5, right? It's what? Negative 2 times 5. So instead of bringing down something, because I'm working in the top, I'm going to bring up the 3, and now I'm going to multiply those two numbers together. What is negative 2 times a 5? Negative 10. Watch those signs. Now I can combine those. What's 3 minus 10 going to make? Negative 7. Good. The signs are different, so we keep the sign of the larger and subtract the numbers, right? And so our completed simplified numerator is just a negative 7. Now in the bottom, drop down there, I have multiplication and I have combining. So what do I do first? Multiplication. So 2 times 4 is going to give me 8, and 8 plus 3 is 11. And will 7 divide evenly by 11? No. Is there any number that will divide evenly into both 7 and 11 at the same time? Nope. So my completed answer is simply negative 7 over 11. Okay. Now, again, that one came out pretty messy because I just made those up. But watch your signs when you're working with these. Okay? So let's just pop over to the book real quickly, and we'll look at a few examples that from the work we're going to do in class. Okay. Go. So look at something like number 6a, for example. I'm going to just rewrite it and then pop over to some better paper. So we have 72 divided by 4 times 2. Okay. I want to simplify this fraction, but before I can do any division, I need to first simplify the denominator. Now, I don't need to worry about the numerator in this case. Why? Yeah, it's just a whole number. It's just one number, so it's already simplified. But in the bottom, I do have an operation, so I need to deal with that. So the 72 won't change, but in the bottom, all I have to do is the 4 times 2, which is 8. And will 72 divide by 8? Yes? How many times? 9 times. So your completed answer is just plain old 9. Okay. All right. Let's look at another one that has a little bit more work involved. Look at something like, oh, I like this one. Look at G. All right. It's always dangerous when a math teacher says, oh, I like this one, isn't it? 30. So we have 30. Oops, sorry. Let me try that again. So we have 30 over 11 minus 2 times 3. This one's not even that bad. All right, first of all, it's a fraction, but before I can do anything with the fraction, I need to simplify both the numerator and the what? Denominator. Now, the numerator is already simplified, so there's nothing I can do there. I'll just bring it over. In the denominator, however, I have a bracket, which I need to take care of. Where does this bracket actually begin? Make me proud, guys. With the negative, with that minus. That is part of the bracket. Okay? So we're going to bring down the 11. Good. Now, when you're dealing with a bracket, there are 3 steps. You don't have to take it off to the side like I'm doing, but I'm doing it so that you can really see exactly what's happening. First, we look inside. Is there anything I can do inside that bracket? Sure. 2 times 3 is going to make what? 6. Then we look for an exponent on the bracket, but do I have one? No. And the last thing I look for is the coefficient or multiplier. And in this case, the coefficient is not a number, it's just a sign. And you can multiply with just a sign. You just do the sign rules without the number part. So it's a negative out here times a what? Positive in there. And what does a negative times a positive always make? A negative. And nothing times 6 just stays 6. So do you see, you can multiply with just a sign. Now, for those of you who've had this before, you might know that there's a little imaginary 1 there. Anytime you don't see a number, you always assume there's a 1. But don't worry about it. What you really need to get used to is just the fact that you can multiply just signs together. Right? That's the first step in working with signs, isn't it? All right. And now we're not quite finished in the bottom. What's 11 minus 6 going to give? 5. And now we can do that division. 30 minus 5 is 6. Okay? So what's happening here is that even though you don't see it, anytime you have a fraction, any fraction at all, it makes no difference. Now, we're not going to do this one. 2 squared minus 3 squared over 4 minus 3 plus 2. Who cares? All right? I'm just doing this as an example. Doesn't matter. Anytime you have a fraction, there is always a bracket around the top and the bottom. But because it's always there, even in this fraction, 2/3 is really that. But because it's always there, we don't need to write it. But you need to remember that it's always there. Because like in this one, it doesn't make any difference, does it? It's as simplified as it's going to get. But in this one, without having the brackets, you might forget that you're supposed to simplify the entire numerator, then to simplify the entire denominator, right? So every numerator and every denominator is always enclosed in a bracket, whether you see them or not, okay? And that's why we have to simplify the numerator, then simplify the denominator, because it's really just following the order of operations. And you'll notice that in mathematics, if there's something you don't have to write, then they won't write it. And that's going to become more and more common as you move forward in the algebra sections. Okay? If they can assume it's there, then they don't bother to write it. Okay? So we'll look at some of those in a moment when we start doing our classwork. But before we do, I want to talk to you about our next topic. And that is working with something called absolute value. Now, absolute value, there's nothing about it mathematically that you're ever going to have to work with. You might solve absolute value equations later in your high school or maybe even university level. But really, absolute value is simply a notation for a specific thing. Absolute value simply means the distance from zero. So the distance from zero. And if you think about distance, so like I see a ruler there. Can you pick that ruler up for me, please? And can you show me where the negative numbers are on that ruler? There aren't any, are there? So think about a tape measure. So if I get a bigger ruler like a tape measure, are there any negative numbers on it? No, because distance is always a positive number. If you walk 10 steps across the room and then you walk 10 steps back, that does not mean you've walked 0 steps. It means you've walked 10 steps and 10 steps, so 20 steps, right? Distance is always positive. So that's what you need to write next. Distance is always positive. So when you're finding absolute value, all you're going to do is drop the sign if it's negative. Just make it positive. So look at it on the number line, for example. Here we have 0. Here we have positive 2. Here we have negative 2. And the symbol for absolute value, is just 2 straight bars. Now, I'm just using an X to stand for any number. Let's use N to stand for any number, sorry. So, absolute value of any number is just the number itself. Okay? But you might want to put a little plus in there because it's always positive. Now, so, what if I want the absolute value of 2? It's simply the distance from 0. So counting from 0, I have to go 2 units. So it's absolute value of 2 is 2. It's 2 units away from 0, right? The distance from negative 2 to 0 is also 2 units, isn't it? Okay, and because we're measuring a distance, it cannot be a negative number. Okay, now, absolute values can be used as grouping symbols. So you need to be aware that you do not do the absolute value of, say we have absolute value of 4 minus 2. We need to do the math inside before we take the absolute value of the number. So that's the absolute value of 2, which the absolute value of 2 is simply 2. Right? So if you have anything to simplify inside the absolute value symbols, you have to do that first. Okay? You could see a number in front of absolute value. And just like a bracket, what does a number in front of a bracket mean to do? What operation? Multiply times, good. So what do you think a number right in front of an absolute value means? Times as well. Doesn't change. Okay? But you have to simplify inside first, so you're multiplying times the absolute value. So let's bring down our 3. 3 minus 10 is negative 7. And the absolute value of negative 7 is 7. So all I've done is I've used the absolute value bars, so I went ahead and put a multiplication symbol there, which gives us a completed answer of 21. So you still have to simplify inside. Then you take the absolute value, and then you would multiply those numbers. So you can see those as a coefficient. Okay? So let's pop over to the book and look at a few examples. Just so you have some examples from what we're going to be doing. Don't worry about those calculator problems. Remember, this is the number section. You are not allowed a calculator. So look at something like 1e. Absolute value of negative 13. There's nothing inside but just the number, right? Absolute value is just the distance from 0, which means it's not going to be negative. It's going to be a positive. So the absolute value of negative 13 is just plain old 13. Absolute value of negative 9. Absolute value of 0. No work involved at all, right? Okay. Now, drop down a little bit, and they're asking you to replace it with is greater than, is less than, or is equal to make the statement true. Absolute value of 7 is what? 7. Absolute value of 5 is what? 5. Which one of those is bigger? 7. So we'd use the is greater than. Remember, the bigger part of this symbol always opens towards the bigger number. Okay? So 7 is greater than 5. Let's look at this one. Look at C. Absolute value of negative 3 is 3. Absolute value of 3 is 3. And so what symbol am I going to use? Equals, because those two numbers are the same. Okay? So always remember, with these symbols, the bigger part always toward the bigger number, smaller part, the point towards the smaller one, right? The mouth always eats the bigger numbers. Yeah? Okay. Let's look down at the bottom where we have a little work to do. Let's just drop down, see if we can find some. Let's do E here. Absolute value of 7 squared minus 8. So we have a little math to do inside before we can do the absolute value. And we have two operations there. We have an exponent and we have some subtraction. So we need to do the exponent first. What does 7 to the second power mean? 7 times another 7, which is 49, minus the 8. So that gives us the absolute value of 41. And the absolute value of 41 is simply 41. Okay? So you just simply do the math inside, then simplify the answer. An absolute value answer is always a positive. Now, there's one case where you get an absolute value and you'll end up with a negative answer. And that's when I have a negative outside. So, because that negative is like a multiplier, isn't it? Let me just rewrite that. So that means negative times. So absolute value of negative 3 is positive 3. That's a multiplication symbol there. So a negative times a positive 3 becomes a negative 3. So that could happen to you, but probably later. They're not going to mess with you too much right now. Okay? All right. Now, so those are pretty easy too, right? So we'll look at those, and then we'll just do work on those two sections. We'll save square roots till later. It's such an important topic. I want to really focus on it a little better. Okay? So what we're going to do is we're just going to go to the book, and we're going to do some work with some fractions. We're going to do some work with absolute values. First, we'll work together, where I'm going to give you one to do. You're going to give you some time to do it, and then I'm going to call on you. Then we'll just have the assignment, and you can work on that on your own. Okay?